Welcome to this video on multiplying and dividing rational expressions, part 1 of 2. Multiplying rational expressions. Let's begin. Let's recall how we multiply fractions. Here we have 2/3 times 5/8. Pause this video and see if you can remember how to multiply these two fractions. So you may recall that one way to multiply these two fractions is to simply multiply the numerators. So we would have 2 times 5 equals 10, and then also multiply the denominators, so then we would have 24. Now, of course, 10 over 24 can be reduced. In fact, both of them are even numbers, so they can be divided by 2, so this fraction reduces to 5 over 12. However, when we multiply polynomials, where we have variables in our numerator and denominator, this method doesn't work quite as well. Instead, we need to use a different method. The first thing we want to do is we want to factor the numerator and denominator completely. In this case, we want to factor any number that is not prime. 2 is prime because it is a product of only 2 in itself. 5 is prime, which is 5 times 1. 3 is prime, 3 times 1. But 8 is not prime. Let's do a prime factorization of 8. Well, 8 is 2 times 4, and of course 4 is also 2 times 2. So a prime factorization of 8 would be 2 times 2 times 2. Let's see if we can make sense of this. So we can rewrite 2/3 times 5 over, and I'll change my color here to draw attention to the fact that 8 is actually 2 times 2 times 2. So then let's see what can cancel out. Well, there's a 2 in the numerator and the denominator, so those cancel out. What are we left with? Well, we have 1 times 5, which is 5. Then we have 3 times 2 times 2, or 3 times 4, which is 12. So again, when we work with polynomials, we need to factor our numerators and denominators first before we multiply across. And the reason we do this factorization is so that we can cancel any common factors, and then we can rewrite it as a single expression. So again, this is just trying to connect existing knowledge. Hopefully you remember how to multiply fractions, connect that to new information, which is multiplying or dividing polynomials.
Let's begin with example 1. So notice that we have not 1, not 2, not 3, but 4 different polynomials, all of which need to be factored. So let's start with x squared minus 9. If you don't remember how to factor polynomials, please go back and watch my whole set of videos on that. So x squared minus 9, you may realize, is a difference of two squares, and it can be factored as x plus 3 times the quantity x minus 3. Then we move on to x squared plus x minus 20. There are 3 terms in this polynomial. You could use the AC method. When you do, you get the quantity of x plus 5 times the quantity of x minus 4. Okay, moving over here, we have x squared minus 8x plus 16. This factors out as x minus 4 times the quantity x minus 4. And last but not least, we have 3x plus 9. We can factor out a 3, so we have 3 times the quantity x plus 3. Okay, so let's go down here to this list of steps. Okay, we have successfully factored all of our polynomials in the numerator and denominator, but notice there's an extra step that we didn't mention in the last slide. It says find and list all of the restricted or excluded values of x. So remember, these excluded values or restricted values come when we try to divide by 0. We can't divide by 0. We actually say anything divided by 0 is undefined. Okay? Now, right now, when we're just looking at the algebraic form of these and looking at the expressions, it might not seem very important. However, when we make this into a function and we try to graph it, we see some really odd behavior when we try to divide by 0. So we're going to start now, and we're going to practice remembering, identifying, and listing the restricted values. So again, the only thing that's problematic is when the denominator equals 0. We don't care if the numerator equals 0 because, 0 over 2 is just 0. That's fine. It's only a problem when there's 0 in the denominator. Okay, so let's just come over here a little bit. Actually, let's do this down here. Okay, our restricted values, or they're also called excluded values. You can use those words interchangeably. I use both of them. Come when either this term, or this term, when any of those terms are equal to 0. Okay, and we can't let that happen, so we say not equal to 0. So x cannot be equal to negative 5. X cannot be equal to positive 4. And x cannot be equal to negative 3. Okay, so these are our restricted values, and they're going to be part of our final solution. Okay, so let's come back up to our factored form of the polynomial and see what terms can get canceled out. So you might notice there's an x plus 3 upstairs and also downstairs. Those can get canceled out. Then we also see that there's an x minus 4 upstairs and an x minus 4 downstairs. Those can also get canceled out. I don't see anything else that can get canceled out, so I'm just going to rewrite the factored form of the polynomial like so. And I'm going to put the 3 first. Usually we put the constant outside, and then we write x plus 5. If you wanted to put 3 on the other side, it is not incorrect. It's fine. Okay. Now, the textbook will say that this is your final answer and you're done. Okay. What I want to see is I want you to write a comma here. Okay. And then after that, I want you to list those restricted values. So we have negative 5, positive 4, and negative 3. Okay. If you want, you can put them in numerical order. I don't care. So again, right now, when we're just looking at the algebra of it all, it doesn't matter. Okay, when it does matter is when we start graphing these and we look at the graph and we realize, oh my gosh, there's a little hole in this graph. It's not defined at negative 5 or positive 4 or negative 3. So we're going to start now and practice those skills. So let's go through our steps to make sure that we did everything. Okay, we've factored everything. We listed our restricted values. We canceled out any common factors. And when we wrote our answer, we included, the information about the restricted values or excluded values. Okay, so let's do one more example. Okay, so let's look at example 2. Before I start this, I just want to remind you a really good way to watch my videos is to pause them before I even start the example. See if you can work the example on your own, and then unpause the video, maybe even speeding it up a bit to watch my solutions. Okay, so first we have x minus 7. Okay, can't really factor him, so just pop them right there. Okay, the next polynomial I see below that is x squared minus 2x minus 35. So we can factor that. Using the AC method, you get x minus 7 times x plus 5. Okay, coming over here, we have 10x plus 50. Okay, we can just use the GCF thing there. The GCF is 10, so we have 10 times the quantity, x plus 5. Okay, then we have 9x plus 54. Similarly, we can factor out a 9. We get 9 times the quantity, x plus 6. Okay, so let's look at our steps here. We have factored all of our numerators and denominators completely. Okay, remember, before we can do the fun and exciting part of canceling things out and simplifying them, we need to think about our restricted values. Again, our restricted or excluded values only come from when we try to divide by 0. We don't care about multiplying by 0. If the numerator wants to be 0, cool, no worries. It's only a problem when we try to divide by 0. So all of these terms, we got to watch them. We got to make sure, wait a minute, they cannot be equal to 0. So just for fun, let's do the excluded values in a different color here. Okay, so we have x minus 7 cannot be equal to 0. We have x plus 5 cannot be equal to 0. And we have x plus 6 cannot be equal to 0. Okay, I don't have to worry about this 9 here because he's just a constant. He's not a variable. 9 is always going to be 9. It's never going to be anything besides 9. So what do we have? We have x cannot be equal to positive 7, cannot be equal to negative 5, cannot be equal to negative 6. So we have 3 different restricted values, and remember, we need to list them as our last step in writing our answer. Okay, so let's go back to the fun part, canceling things out. So the x minus 7s, they go away. Okay, what else do we have? We have x plus 5 also goes away. So let's see what's left. Upstairs, it looks like the only thing that's left over is a 10. Downstairs, in the denominator, it looks like there's a 9, and then times the quantity x plus 6. Okay, again, the textbook will probably tell you, or even if you do your online homework, it'll say that's fine, you're done. Okay, but what I want to see, because this is really good practice for the future, is we are going to list the restricted values. So x cannot be equal to 7 or negative 6 or negative 5. I don't know why I put those in those order, but there it is. Okay, if you don't like that it's on 2 lines, you can just write a comma here. You can put them all in 1 line like this. Okay, 7, negative 5, negative 6. If you want, you can rearrange it from smallest to largest. I didn't bother doing that. Okay, so when I grade your homework, this is what I'm looking for. I want the reduced expression. I also want you to list the restrictions on x.